Now, for building better measures, measures that are not biased that way, we take our building blocks and we combine them in a few more ways. So here are some basic combinations. False alarm rate, also called the false positive rate. So this is, it's basically the number of false positives divided by the total number of false positives that we could have made in the worst possible case. So the total number of false positives in the worst possible case is just the total number of negatives, right? So the total number of negatives in the system, our system could have predicted every one of them as positive, right? So we take the number that it's actually predicted as positives, the false positives, and divide it by the total number of negatives. So that's the false positives divided by false positives plus true negatives. So think of it as the proportion of negatives that our system mistakenly thought were positive. That's the false alarm rate. A miss rate is a complement of that. So it's the percent of positives that we incorrectly misclassify as negatives. So out of all positives, that we have in the system, that's the true positives plus the false negatives, how many of them did we get wrong? That's the false negatives out of all the positives. It's known as the miss rate or the false negative rate. The flip side of the miss rate is something called recall, or it also is called true positive rate. So it's just 1 minus the miss rate. It's the percent of positives that we classified correctly. So it's the number of true positives divided by the total number of positives, which is true positives plus the false negatives. And another metric which is kind of useful, but it's different from the other three, is precision. So precision is out of everything that our system thought was positive, what fraction of that was really positive. So take a second at some point, make sure that you understand the difference between recall and precision. They seem to confuse a lot of students. They're really measuring two very different things. So this is percent of positives that we classified correctly out of all the true real positives, and this is the percent positive correctly out of what we predicted were positive. Two very different numbers. Now, it's interesting, but any one of these numbers by itself is not a good measure of accuracy because you can come up with silly little classifiers that will easily get 100% or a 0% on any one of them. So it's trivial to come up with a system that has a 0% false alarm rate or 0% false positive rate. You just say no to everything. You say no to everything, you're never going to make a false positive, right? Just by definition. It's also easy to get a system that has 100% recall. You say yes to everything. This means you're guaranteed whenever there was a positive, yes, you would have said yes to it. You said yes to lots of negatives as well, but recall doesn't care about that. Recall only cares about the positives. So individually, you can make every one of these measures as high or as low as you want. So in practice, you never ever report them by themselves. You report them in pairs. And the typical pairs are recall and precision together. So that's used in a lot of fields. Or you use miss and the false alarm rate. That's popular in the detection literature. Or you use true positive, false positive rates. That's more common for the classification literature. So you always, the thing is you always report a pair. You never just report one number because one number could be arbitrarily high.